Hello everyone, my name is Mohammed Al-Amir and today I will present my research paper on this conference under the title that Enhanced Performance Analysis for by using combination of beamforming technique and direct receiver. So I will turn off the light to be clear for you. So in a recently year, the demand for high data rate watch was increased for the new generation of the wireless communication, and we propose in this paper two of this requirement for the 5th generation. And we believe also the key terminology to achieve this requirement is combine the proper application of the channel coding and the modulation and also the MIMO technology. So the MIMO technology, which is one of the most modern technology that we use in wireless communication, and also which is used to increase the reliability or increase the data rate of the communication channel. As a way that the focus of the MIMO technology to increase the reliability by increasing the diversity of the system, such as use space-time coding to increase the spatial diversity, or there is another way to increase the frequency diversity or time diversity. Also, if we focus on the MIMO technology to increase the data rate by using the spatial multiplexing, and there is two ways to create the spatial multiplexing: is the layer space-time coding or beamforming technique. So almost all wireless communication channel is multi-path channel. So due to the propagation mechanism like reflection and sectoring and deflection also. So that's caused to receive the signal at the receiver with low power. So there is a 4 type of fading, which can classify the communication channel, which is under one of these type of this fading, depend on time dissipation and frequency dissipation, like delay, separation of current bandwidth, Doppler spread and current time. This can decide which is the channel, which kind of fading this channel with it. So there is a flat fading channel, a frequency selective fading channel, fast fading channel, and slow fading channel. So also we give you the brief description of the diversity. Is basically we send the same signal over the different transmitter antenna, so that at the receiver we receive the signal with the replica of the signal at the receiver. This replica of the signal is which is separate from the independent noise, independent fading. And spatial multiplexing, that means they transmitted the different data stream of the different transmit antenna. So there is two ways to create spatial multiplexing, and we are workers, and also in this paper we'll investigate and analyze the second way, which is beamforming technique. Also in this paper we assume the channel is under the flat fading channel, really fading channel. We use modulation, we use the multipath component of the signal to create the dynamic diversity. That's all by using the direct sequence spread spectrum will be the scale modulation. The beamforming technique is we can consider as a practically way to create the spatial multiplexing with using a beamforming technique. And we believe also that the beamforming is a promising technique for the massive MIMO on 5G. And in this paper we show that how to achieve simultaneously the spatial multiplexing and also spatial diversity. So here we divide the MIMO channel by applying single or variable decomposition, which is a technique of the beamforming technique. Decoupling the MIMO channel to the sub-individual channel. Each of this channel independent. It has independent noise. Also, with the summation, the capacity of this MIMO channel will be the summation of this sensor channel. And also, each of these channels has first order diversity. And we use the rack receiver to combine the multi-path component, which is the time, which is delay version of the original signal. And by correlation at the rack receiver, we correlate the signal with the time shift version of the correlation of the original signal. So we'll extract this multi-path component and combine them by using maximum ratio combiner. That will increase the signal to noise ratio for each subchannel. Using direct signal split spectrum modulation, just as we separate the data modulation signal as the second modulation with the BN with the BN sequence. So the BN sequence, if we don't have the same BN signal, the receiver will not receive the signal. So this kind of system is considered a very secure system and is anti-interference system. Could use this system to reject the multi-path component or exploit them by using the rack receiver. Here, what we did, first we used a single value decoupling MIMO channel to some individual channel with a gain, beforming gain. Model of all of these channels with a multi-path channel using direct sequence spectrum modulation with VSK, and using the rack receiver at each sub-channel to extract the multi-path component of each sub-channel, using the maximum ratio combiner to combine this component and increase constructively to increase the signal to noise ratio. Using the Maxwell logarithm to detection extract the original signal. We assume that there is interference coming from the adjacent signal, also from the multipath. Also, we combine the result with the result we have gained by using only beforming technique. For symmetrical system, we use the beforming technique to divide the MIMO channel to sub-individual channel, and there is a multipath component, and the interference comes from other sub-channel, and there is a gain for each sub-channel, which is sigma 1, sigma 2, and this has some properties by using single value decomposition. Sigma 1 is bigger than sigma 2. This also we model each of these sub-channels with a multipath equation. And here are the correlation. Here the process correlation signal. At the correlation, we correlate 4 components at each finger of the rack receiver, which is the correlation with the desired signal, correlation with the multipath component, and the correlation with the multipath is coming from adjacent signal and with the noise also. At the end, we find the average of the signal to interference ratio. That by finding this average, so we'll calculate the capacity and reliability of bit error for each subchannel. By increasing the reliability of each subchannel, overall we increase the reliability of the MIMO channel also. Here is the subchannel 1 for this symmetrical system, and subchannel 2. We can see in the right one simulation result by using the rack receiver and beforming technique, and we can see under the blue one the simulation result by using the beforming technique with the VSK. And also for subchannel 1 and subchannel 2, there is a difference because there is a gain difference between these two subchannels. Also, the capacity will be increased because we're using maximum ratio component at the rack receiver. That will increase the signal to noise ratio that we don't have it at the system using the beforming technique only. For the system, non-symmetrical system, 2x3 system, also there is 2 sub-channels because the number of the sub-channel is equal to the lower number of the transmitter or receiver antenna. So there is also we can see the difference. It has better performance than the system we have 2x2. We compare them here. The blue one in the system have 2x3, and the red one system have 2x2 simulation result. Also here for sub-channel 1, because there's different by using three transmitter, we use the antennas share to detect both signal, so that one combine them using maximum ratio combiner, so that will increase signal to noise ratio, and that will increase the reliability and the capacity of the microphone. So the system has 2x3 is better than system has 2x2. And then we increase the reliability of the MIMO channel. We increase also the capacity of MIMO channel. Also we have the detection the signal parallelly, so that error will not propagate that maybe exists in the serial detection. Also for the future, there are many opportunity for increasing, for example, increasing the number of transmitter and receiver and using different type of modulation like BSK and PSK or QAM, or we can analyze this proposal question and the different type of fading channel like frequency selective channel, fading channel. So by using MIMO and our DM technique. Thank you for listening. Have a good day.